Hi. In this video, I'm going to talk about the worksheet about get ready balancing chemical equation number 1, synthesis and decomposition. So synthesis and decomposition, they are actually opposite of each other. So there's like no much difference of how to balance them. But I'll go ahead to show you some questions for that. So first of all, I'm going to pause the video. I want you to copy this notes onto your worksheet. So you want to pause the video and then cut these notes down on your Get Ready worksheet using color pens, okay? Right, so right this moment, I assume that you already copied the notes. So I'm going to talk about this. So balancing equation is a very important concept in chemistry because it's talking about if you have a reaction take place, you cannot have something disappear, you can have something created suddenly, you can only change the form, so you need to make sure that the atoms on both sides of the equation are balanced. So that balancing equation is actually coming from the concept of law of conservation of matter. In this law, it says that the matter cannot be created or destroyed in a system. That means that I cannot suddenly create something, I cannot suddenly destroy something. I can only change the format. So in other words, the amount of the matter must stay the same before and after the chemical reaction, even though the form of matter could be changed. So for example, here I got H2 is a liquid form. So H2 meaning I get 2 hydrogen before. And after the reaction take place, I have 2 H plus ions. So I still have 2 hydrogen. But the form of the H is no longer liquid. The form is no longer element. It will be like a H plus ion. All right, or I have a 2 Mg2 plus, I get 2 Mg ion 2 plus ion before reaction, and after reaction I get 2 Mg solid. So before and after I get 2 Mg, but the format will be changed from ion to solid. Okay. And then the second concept is when you balance equation, right? How do you know that you balance the equation correctly without keep asking me or without keep asking the teacher, Mr. Chen, can you check the answer for me? You don't have to ask me because you have a way to check. How do you know that you are doing that correctly? Is you want to check if the numbers of the atoms on both sides of the equation are equal by drawing and completing the atom table. So you got to draw this atom table, and then you can look it up the atoms before and after, meaning on the left side, on the right side, are they equal, right? Then you can tell that your equations are balanced correctly. And when I calculate the total number of the atoms will equal to coefficient times subscript. So for example, if I give you 5H2, so how many H is actually the coefficient? 5 times the subscript, which is 2. So 5 times 2 will be 10H. If I get 5 bracket H2O, all right, so the oxygen will be actually equal to 5 times, actually, this is not H, this is actually this, okay? This will be like a 5H2O. How many H? That will be 5 times 2 will be 10H. And I will also have 5 times 1 equals 50. So would you please fix the notes that I got here? Okay. And that's how you calculate the atoms as coefficient times subscript. And if the same atoms, they are on the same side, you can add that up together to see how many. So for example, this is the equation, H2O2 plus O2 equals water. So how many O on the left-hand side will be actually 2O plus 2O, 2 plus 2 on the left-hand side. And on the right-hand side, I will get 1. So, and later you will balance it. And right here, make sure that you never change the subscript. So for example, H2O2, all right? So H is balanced, right? Because both sides will be 2H and 2H. But oxygen, I got 2 here. I only get 1 here before I add the red color on. So you don't want to just put the color red 2 here to tell that, okay, I have 2 oxygen, because you're changing the formula. Like you're supposed to have hydrogen peroxide, H2O2. You cannot put the 2 there to try to make the oxygen balance, because you're changing the water to be hydrogen peroxide. They're 2 different compounds. So you cannot change the subscript, right? So you cannot put any subscript number to make the balance, okay? So what can you change? Then you can only change the coefficient. Coefficient is the number you can only change, and it must be a whole number and no fraction and no decimal. So which one is the coefficient? Is for example, this one, the 2 in front of the compound will be the coefficient. So you want to put the coefficient in front with a bracket around a compound. So if it's a compound, you want to put a bracket around before you put the coefficient outside. So for example, KCl is a compound, you want to put a bracket around KCl and then put the 2 outside to indicate that, okay, I get 2K and 2Cl. If you forgot to put the bracket outside, many people will say that I get 2K but 1Cl, which is a mistake. All right, Na2SO4 is also a compound, so you want to put a bracket outside before you put the 2. So then how many Na you will have? You will get 2 times 2, which is 4Na. 2 times 1, if there's no number on the S, we know that it's 1. So 2 times 1 will be 2S, and then 2 times 4 will be AO. So if you did not put the bracket outside, you probably only remember, okay, I got 4Na, but you will not realize that you get 2S and AO. You will say that, okay, I only get 1S and 4 oxygen, which is wrong. So make sure you put a bracket around the compound before you add the coefficient. And do not put the 1 as the coefficient until the whole equation is balanced by checking the atom table. So the 1 is the last thing you want to put, unless you're sure that everything is balanced. Then you can go back to put the 1 on the blank coefficient. And you always want to check if all the coefficients have been in the most simplified form. So if they're not, you want to reduce all the coefficients to the lowest multiple as possible. So for example, if I get my coefficient 2, 4, 2, 2, sometimes you think too beyond, you think too much, and then you make the coefficient too big, 2, 4, 2, 2. Well, you always want to check if all the coefficients are in the most simplified form. If not, you need to simplify. So in this case, my lowest number, the largest, you guys call greatest common multiple, greatest common factor is 2. So then I will divide everything by 2 to get 1, 2, 1, 1. Okay. And then in order for you to cross out the atom in the table, we've got to follow the order. Is blue, number 1, we use blue pen, and then green pen, and then red pen, and then black pen, and then we're going to continue to repeat it again. All right. So first of all, I'm going to do some synthesis equation. So I give you like a blank equation with no coefficient. So the first thing you want to do is you want to add the equal sign on 2 areas. So I'm going to use black pen. You want to add the equal sign on 2 areas. So you want to add onto the top of the arrow, right? And also you want to put the equal sign between left and right here. So to indicate that anything on the left, anything on the right, all right? And then next is you want to type the what kind of element you can see. So I have Ca in the equation. I also have O in the equation. All right. And then you're going to look up the arrow. You're going to look up the arrow, and anything on the left hand side of the arrow will be left. Anything on the right hand side of the arrow will be right. So you want to look it up. How many Ca do you have at the beginning on the left hand side? So on the left hand side, I only get 1 Ca. So I'm going to use blue pen to start. Okay. So I'm going to use blue pen to start. So on the left hand side, sorry, good, like this. Okay, so on the left hand side, right, of the arrow, I get 1 Ca. All right, and then on the left hand side, I got 2 oxygen. Okay, on the right hand side of the arrow, I got 1 Ca, and then I got 1 oxygen. So you want to look it up. Ca, they both have 1 and 1 on left and right. So Ca is balanced. But O is not balanced because O is like 2 and 1. So how you going to start it? So actually, before you start, I forgot to ask you to do one thing. Before you start to do anything, when you see the compound, you always want to put a bracket before you start. So this is the first thing you want to do. So I put a bracket around CaO. Because CaO is compound. You don't need to put bracket around CnO because they are element only. All right, so you put a bracket first. And actually, I'm going to put the equal sign here too. I'm going to use red pen. Maybe was that easier? Would that be better? All right, I'm going to start with this. Okay, red pen to put the arrow, the equal sign, and the bracket. All right. So we see that the calcium is not balanced. I mean, the calcium is balanced, but oxygen is not balanced. So we're going to use the second pen will be green. So how can you make the O balance? So you want to make the O balance by putting the number on the equation first, then put the changes on the table. Next, do not change the table without putting the number here. Many people screw this up is because they go ahead to make the 2 here, changing the oxygen to be 2, but they forgot to put the numbers on the equation, which is really wrong. So you want to, when you decide, okay, I want to make the oxygen 2, I have to put the 2 in the equation first before I change the table, because you are not just changing the oxygen, you are changing calcium after the put a bracket. All right. So I want to make the oxygen by 2, so I have to put the 2 on top of CaO. Now this bracket indicate that I'm not just changing the O, I'm also changing the Ca. So Ca no longer 1, but will be 2. Right? And O will no longer be 1, but then will be 2. Now you can say, okay, my oxygen is balanced, but my Ca now become not balanced. So I'm going to use the next pen will be green. Will be red. So how can I make the Ca balance? Okay, I'm going to go back to change the equation first. Okay, so I'm going to add 2 Ca right here, right, and then make the Ca become 2. All right. Now finally double check: is Ca balanced 2 and 2? Put a check mark. Yes. If the O and O is balanced 2 and 2, check mark. So after now I know that is everything's balanced, finally I have any blank thing, then I will put the 1 over there. So after I want to share this balance, I put the 1 there. So that make this equation 2, 1, 2. And also 2, 1, 2 is the most simplified. I don't need to divide it by any number. So this is done. Okay. So number 2, I'm going to actually put all the equal sign. I'm going to do that for everything. So put the equal sign with the with the blue pen. So you want to go ahead to do it. So put the equal sign on the arrow and also the between left and right. All right. Another thing you want to do is also, I forgot, right? Another thing you want to do is add the bracket around any compound. So I got NH3 will be compound. I got this will be compound. And water will be compound. So again, you only need to put a bracket around the compound. So let's do this for now. Okay. So I'm going to start with blue pen. All right. We're going to start with blue pen to write down how many. All right. Actually, I'm going to type the letter. So number 2, I get N, and I also get H. Okay. I get N and so H. So the on the N, on the left hand side of the equal sign, I got 2N. And then I got 2H. And on the right side, I got 1N and I got 3H. All right. So you can see that I can either balance N first or I can balance H first. It doesn't really matter. Your work could be different, but your final answer should be the same. So it doesn't really matter which one you balance first. So there's a little trick here. All right. So I'm going to introduce you the trick here. The trick is, if you see 1 is a even number, 1 is a odd number, the best thing to do is multiply these 2 numbers to get a final number. All right. So again, let me say it again. If you see the total coefficient, one is the even, one is the odd. The best way to do is multiply. So 2 and 3 is a very common one that you will see. So I'm gonna multiply 2 and 3. 2 is even, 3 is odd. I multiply 2 and 3 to get 6. That means I want the h to be 6 on the left hand side. So in order for me to get the 6 on the left hand side, will be 6 hydrogen. That means I have to make this to be 6. So I change the number on the equation first, then I change the number on the bottom. So I want 6, right? I want 6. I want 6 on the left hand side. So I have to put 3 here to make 3 times 3 is 6. And then on the right hand side, I also want my h6. I also want to my h6. In order for me to want to have the h6, I have to put 2 here. But then when you see that you put a 2 there, you're actually not just changing the h, but you change the n. So you start from the beginning. You change the n on the right-hand side from 1 to 2. You're also changing the h from 3 to 6 because 2 times 3 is 6. Okay, now you can simply see that, right? 2 and 2 on the nitrogen, balance, put a check mark. 6 and 6 on the hydrogen, balance, check mark. Then finally, you will put the 1 on here to make it balance. If you're changing the n first, you can also get the same answer. Your work could be different. Your work could be different, but you should get the same answer. Okay. So on the bottom here, I got Al, right? Al and O. So I'm going to type Al and then O, right? And then on the left-hand side, on the left hand side, right, I have equal sign. On the left hand side, I got 1 Al, and then I got 2 O, and on the right hand side, I got 2 Al, and I got 3 oxygen. So you can see again, I have the same situation. I got 2 and 3. So the best way to do is multiply them to get 6. So I want 6. So I want O, right, oxygen, right, 2 and 3 to be 6. So how can I make the oxygen 6? I have to multiply, I have to multiply by 3 to the oxygen. So I multiply by 3 to oxygen. So when I multiply by 3 to oxygen, I make that to be 6. Okay, and then I also want 6 oxygen on the right hand side. So I have to put 2 here to make oxygen 6. But once I put the 2 here, I'm not just changing the oxygen, I'm also changing the Al. So Al will no longer be 2, but Al will be 4. Then oxygen will be 2 times 3 is 6. So now you can see that oxygen is balanced, right? Oxygen is balanced. Oxygen is balanced, but Al is not balanced. So we're going to go to the next color. We get a red color. So how can I make the Al happy, right? So I need to change my Al right here. I need to change that to be 4. So then my Al will be changed to 4. Okay, now you can see that, right? You can see that. Is Al balanced? Yep, Al 4 and 4 balanced. Is my oxygen balanced? 6 and 6 also balanced. All right, so then no blank number. I don't need to put the 1. And 4, 3, 2. Again, you always check the final coefficient. 1, 3, 2, 1, 3, 2, right? 1, 3, 2, and 4, 3, 2 are the most simplified. Okay. All right, so next one, I'm going to have H and O. Right, and then I'm going to start with blue color. So now the left hand side of the equal sign, I got 2 hydrogen. And on the left hand side, you have to be careful here. I get oxygen. But they show up on two different chemicals. When it shows up on oxygen, shows up from water, when it shows up oxygen. You know that you come up with 3, end up with 3, but you don't want to write 3. You want to separate them to write 1 plus 2, right? I got 1 from water, 2 from oxygen. Now, why you want to write it that way? Because when you are changing the coefficient, you don't always need to change everything. Sometimes I only change the 1. Sometimes I change the 2. Sometimes I change both, but with different number. So you want to write them separately, then you will not bother you. All right. And then on the right hand side, I got 2 hydrogen and then 2 oxygen. All right. So this is what I start with. Okay. So now you can see hydrogen, it looks happy, but oxygen is not happy. So remember that something you want to remember, O2 is a diatomic element. So diatomic element want to have even number. They don't want to have odd number, right? So O2, oxygen does not want to have odd number. So I need to change the odd number to be even. So the best thing to do is change this, the left-hand side, the oxygen, from odd to be even. So I'm going to change that to be 2 here. Oh, I'm sorry. I don't want to do that. So I want to change the left-hand side oxygen to be 2. Okay? I want to change the left-hand side oxygen to be 2. In order for me to change it to be 2, that means I want to put the 2 here first. Now you see that sometimes I did the same thing. Like I changed the number here first without changing the number on the top, and I forgot to change the hydrogen. So you don't want to do the same thing. You want to add the numbers on the equation first, because you might need to change something else besides the oxygen. So always do not change the number directly here in the table unless you have the number in the equation. So I want oxygen here will be 2, so I put 2 in the front of the H2O. That means I'm not just changing the oxygen, I'm also changing the hydrogen also. Okay, so my hydrogen become 4, right? 2 times 2 is 4. And then my left-hand side oxygen will become 2. All right. Now you can see that none of the word is balancing. So you want to see what you can change. Okay. So maybe I'm going to change the I want the hydrogen to be balanced, right? So I want to put the 2 in front of H2O2, right? I'm going to put 2 in front of H2O2, right? So I'm going to make hydrogen on the right hand side will be 4. And then I'm going to make the right-hand side of the oxygen 2 times 2 is 4, so 4. All right. Now, read carefully. All right. Read carefully. Okay. Right. Hydrogen is 4 and 4. Oxygen on the left-hand side, 2 plus 2 is 4. On the right-hand side is also 4. So now they are balanced. You see how you read it. Right? 2 plus 2 is 4. On the right-hand side is also 4. Then now I can put the 1 in the middle as the equation. And 2 and 2 is not like multiple. So it's more simplified. Okay. Now here on the last one, I'm going to do the same thing. I have to put the equal sign on the top of the arrow and the between left and right. And also when I see the compound, I put a bracket. Same thing right here. Okay, so I'm going to start with, like this time, like decomposition. Decomposition is actually opposite of the synthesis, like the direction is opposite. So the way to do balancing is the same thing, okay? It's not much difference, okay? It's just like flipping of the synthesis. So here I got I got 3 elements, right? Li, Br, and O. So I'm going to start with blue pen. Right? So on the left-hand side, I get 1 Li. Sorry. On the left-hand side, I get 1 Li and then 1 Br and then 3 oxygen on the left-hand side. On the right-hand side, I get 1 Li, 1 Br, and then 2 oxygen. Right? So again, we have something like similar to before, is when I have an odd number and an even number, the best way to do is multiply them to get the final number. So 3 times 2 is 6. So in order for me to get 6 oxygen on the left-hand side, right? In order for me to get 6 oxygen on the left-hand side, I have to put 2. Then I change not just the oxygen, I change the whole thing. So I change my Li to be 2, my Br to be 2, and then my oxygen to become 6. Now, why 6? Because 3 times 2 is 6. On the right-hand side, right, I want my oxygen to be 6. I want my oxygen to be 6. That means I'm going to put the 3 here to make my oxygen 6. All right? And then I'm going to do the last step, which is here. Now you want to look it up, right? Li and Br is not balanced. Oxygen is balanced, but Li and Br is not balanced. So I have to put the 2 in front of the Li, Br to change the Li on the right-hand side to be 2, and then the Br on the right-hand side to be 2. Okay, now check. 2 and 2 balance, 2 and 2 balance, and then 6 and 6 balance, and I have no one number left over, so this is good. 2, 2, 3 is also simplified, right? Here I got 2 atoms, so Na and O, and the Na on the left hand side I got 2. On the left hand side I got 1 oxygen. On the right hand side I got 1 Na and then 2 O. All right, again, it doesn't really matter which one you start to balance. Your final answer should be the same. As like you're in the middle of the work could be different, but as long as you balance correctly, it doesn't really matter which one you start with. So let's say you can either do the Na or the I. Okay, I'm gonna try the Na. Okay, you can change the O first. It doesn't matter. So I'm gonna change the Na. So I have to make the Na balance. So I'm gonna put change my Na. So I'm gonna change this to be 2. Then I will change that to be 2. So N is balanced, but O is not balanced. So I have to make the O, right, 1 times 2, right? I have to make the O to be 2. In order for me to make the O to be 2, I have to change this to be 2, right? I have to change the left-hand side, put the 2 in the middle, put the 2 in the front. But now this time, I'm not just making the O change. I make the O, Na also 2. So Na, I change that to be 4. And then my O is 2. Now you can say, hey, you know what? Before my Na is balanced, now my N is not balanced. You can actually change it again. So how are you going to change it, right? My O is balanced, my N is not balanced. So how can I change it? You can actually cross it out, the one that you have before. Of course you can do that. You change my N, you change that from the 2 to be 4 now. So I change it to be 4. You can do that. So finally, you're going to look up, right? Na, 4 and 4 balance. Oxygen 2 and 2 balance, so then I will have the leftover 1 here. 2, 4, 1 is balanced and also more simplified. So there are many ways you can do. So the best, again, as long as you put the bracket around the coefficient, you put a bracket around the coefficient and put the bracket around the compound, and then it doesn't really matter which one you start. And this is how you got to do it to work. So this is the final page. See how you did that. All right, this is the final page.